Innovative global integration personnel have over 70 years of combined financial industry experience with global financial institutions. IGI's primary goal is to consolidate data architecture, upgrading current systems while providing flexible, scalable, and upgradable data architectures. The Protocol Transformation Engine Dynamic Network Architecture, PTE DNA, is designed to minimize code and maximize focus on the business process. This is accomplished through the complete use of metadata, data about data. The term protocol, as used in computer systems, is defined as a set of rules and regulations that determines how data is transmitted and interpreted. This definition appears confusing to many people. To simplify this concept, the term protocol can be said to be any set of rules to communicate information. Everyone does this all the time. Every time you speak, you are using a protocol, the language you are speaking. Human beings use many languages and many ways to communicate with each other. We communicate as we speak. If we are sitting with each other having a meal, we may also use gestures as part of the communication protocol. 50 years ago, talking to each other remotely required a hardwired device. We would have to be in a physical location of the telephone to call someone. Today, virtually everyone in the world carries a smartphone with them wherever they go. These devices allow us to communicate with protocols other than just language. We can take and share photos and videos. We can use these devices to send emails. If we take the United Nations as an example, we have delegates from all over the world speaking different languages. When any individual delegate speaks to the assembly, they use their native language. This system requires that there are translators available to perform the task of translating from any language to any language. This ensures that everyone can speak and listen to anyone else using their native language or protocol. The fundamental premise of IGI's Protocol Transformation Engine Dynamic Network Architecture is identical to the concept of translators at the UN. Even within a specific language or dialect, there are sub-protocols that are specific to given tasks or domains, where it will require specific domain expertise in order to understand the rules and regulations for the specifics of the sub-protocol. Examples of this could be construction workers discussing logistics at a site, farmers in a vineyard discussing how long it will be until the grapes are ripened, or chefs discussing the preparation of a meal. PTE DNA manipulates metadata to create software for data integration, content integration, application integration, B2B integration, B2C integration, business process management, composite applications, staged migration of legacy systems. Occam's razor, the law of succinctness, is the principle that entities must not be multiplied beyond necessity, and the conclusion thereof, the simplest explanation or strategy, tends to be the best. IGI endeavors to use Occam's razor as the underlying principle of all our work. Using the principles of Occam's razor, we describe things in the simplest ways possible. For example, we have described any business transaction as one or more pieces of data, text or numbers, that can be combined, split, or calculated. Many times we've been told that in order to automate a business process, it is necessary to have domain expertise. In actual fact, this is not true. Interpretation of the information is only needed by the individual using the tool or computer system, not by the computer itself or the programmer. If we have data containing name, quantity, and price, for instance, corn, 10,000, $4.59, and gasoline, 1,000, $2.52. The programmer displays this data on the screen for the user. Both the computer and the programmer do not need to know what the information means, only where it comes from and what the transformation or calculation is and where it is to be displayed. If the individual using this information is a farmer, then the information may mean the amount of corn left in storage and the amount of gasoline available for the tractor. Using this information, a decision can be made about how much corn needs to be planted and if there's enough gasoline to accomplish this task. On the other hand, if the individual is a commodities trader, then the information may represent the quantities in a portfolio and the current price. Using this information, a decision can be made about how the portfolio will be managed. This example should make it clear that the domain expertise is required only by the person using the information, not by the computer system or the programmer manipulating the information. It is a label that is displayed along with the information that gives it meaning for a specific domain. The original premise of PTE DNA was developed from the concept that a software application can be created dynamically by creating a matrix of information where each connection point performs a single action or function upon the current state of the information, transforming or translating it if necessary. This is accomplished through the separation of content, data, from context, metadata, data about data, and both of these from actions, the implementation of functions using code. These simple functions can be composed or aggregated to create complex functions using a combination of simple functions. PTE DNA enables data integration through metadata manipulation. Why has the hammer become more important than the house it is intended to build? Do you seem to be spending as much, if not more time, maintaining, upgrading, and servicing your software systems rather than running your business? The world changes faster than you can change your applications or website to accommodate these changes. You are losing money every minute that a business issue exists that is not addressed. Unless your product is software, implementing a set of tactical, partial solutions that achieve the strategic, complete goal is not only expedient, it is critical. Tactical to practical, the most important first. While implementing a complex claim processing system for a large insurance corporation, it came to our attention that as they had actually identified the cost of business at $10 million a month, implementing a 20% solution in 60 days created a situation where they covered the cost of development while completing the project. Billions of dollars have been invested annually in expanding enterprise systems and databases over the last 3 decades. During this time, there have been rapid advances in computing architectures. However, there has also been little concern for backward compatibility and investment to date. The equity is in the data, not the applications or the infrastructure. Functionality is buried in data silos, which are increasingly difficult to manage and integrate. Cumbersome infrastructure and cumbersome deployments lead to the loss of agility and the inability to move fast or respond quickly to competitive pressure. This produces a self-perpetuating cycle: more layers, more tools, more congestion. Programmers and web designers create code and markup that acts in a static manner. This results in a system that is fixed or hard. They have to modify the code, usually in multiple places, to make alterations. The key question becomes, shouldn't software be soft? Most projects are designed to use existing resources. Most legacy systems still have benefits that can be realized. This leads to the question, how do you get the most from your current investment? New data feeds or services need to be integrated into existing applications or services. The new and the old systems have minimal communication, therefore integration requires development. Which leads us to ask, what is the best way, time, money, quality, to integrate all of these services? PTE DNA has been developed to address the fundamental inadequacies of current software systems. We have progressed greatly from the days of flipping switches on a panel. From assembler languages to high-level languages, markup languages, IDE development tools, to task-oriented tools. PTE DNA leverages information from a wide variety of storage types, environments, applications, databases, and other data sources. This allows enterprises to deliver value-added processes to employees, partners, and customers with substantially fewer resources, substantially less time, and substantially reduced cost by migrating legacy systems in a staged manner. PTE DNA is a breakout technology, providing metadata integration, language and data source agnostic. It's highly scalable, centrally managed, significantly reducing implementation time and cost, making software soft. PTE DNA provides many advantages: simplicity of use, non-invasive with existing systems, greater adaptation to changing requirements and environments, create more efficient applications from existing systems and databases, encompassing entirely new applications, processes that combine, normalize, and present data from multiple sources, processes that automatically exchange information between back-end processes. PTE DNA is a revolutionary integration platform that streamlines the process of creation and maintenance for information services within and across enterprises. This gives organizations the technology to support change, distributed and centrally managed, works across platforms and networks. Scalability is purely a hardware issue. Simplicity of implementation and maintenance, non-invasive with existing systems, greater adaptation to change in requirements and environments. Act because inaction is decay. Dynamic distributed applications, integration, data, events, signals, legacy systems. Failover, distributable, real-time, high availability. Advanced functional composition of applications. Multiple devices. Problem solved. Management of large composite applications, back-end and front-end services. Extremely inexpensive to operate and maintain. Simple metaphors, standard tools. Achieve strategic goals through tactical steps. PTE DNA's unique architecture and implementation approach simplifies integration across disparate technologies, platforms, and organizations. Save time, save money, do more with less.